Hey guys, Dave Municello here from GV. Really excited today to have a conversation with Frederic and Kelsey, who both worked at CoreOS. CoreOS is and was a beloved GV portfolio company. Alex Polvey and Brandon Phillips founded it and hired in just a bunch of amazing people like these two that are here with us today. And I'd love to chat with them a little bit more about what they're up to now and learn about Polar Signals, Frederic's company that he founded, and that the three of us partner on. So let's kick it off. First, why don't we do a little bit of introductions? You want to give like the 30-second who are you and why are you here sort of overview. Maybe we'll start with Kelsey.
Hey, Kelsey Hightower, currently at Google Cloud. I call myself a tech practitioner. Lots of work in the open source space, and my specialty is all of this cloud native infrastructure stuff, and pretty excited about what's going on today.
So I'm Frederic, founder of Polar Signals, and I guess that's why I'm here, but I'm super interested in all things like cloud native observability, and that's really where a lot of my background is as well. And Polar Signals is also about observability, but also kind of stepping outside the traditional norms of observability and kind of trying to expand the horizon.
Kelsey, we've teamed together on 4 or 5 portfolio companies, and nearly every one of them is like, if Kelsey would ever do anything more than being an advisor, like, please let us know immediately. So it's been great to team with you. So I'd love to start out, maybe if we can start even before Polar Signals was created. You two worked together at CoreOS. GV invests deeply in open source technologies. We named a bunch before this call, but stuff like vectorized thread panda or Upbound's Crossplane, Cockroach Labs, GitLab, Polar Signals, and others. Would love to hear, what was it like to team together at CoreOS? What was the story of like sort of how you guys got to know each other there?
Yeah, I joined CoreOS. I think there were probably like 10 people, so this is probably before Frederic may have joined the team. But I remember the mission back then was, funny enough, Google's infrastructure for everyone else. And CoreOS just went on this execution like rampage. We built tools like etcd, the container networking interface. We did a lot around the container and infrastructure management stuff. Funny enough, we didn't really get to the observability part of the Google infrastructure. I think this is what Polar Signals is bringing to the market. But we just started bringing in people from all around the world, like it caught fire. And so we started bringing in talent to help us kind of fill in the gaps across the portfolio. But there was this huge infrastructure play, so we had to bring expertise from around the world, and I'm pretty sure that's around the time that Frederic jumped on board.
Kelsey, I think we missed each other by like 2 months. So yeah, I was like one of the first engineers here in Berlin, and I worked immediately on all things Prometheus and everything in the intersection of Prometheus and Kubernetes. And pretty quickly, I became like maintainer for Prometheus and ended up creating a lot of the integrations within Tectonic, or for those who don't know, our like Kubernetes distribution back at CoreOS that we were developing. And so I kind of became the person that was doing all the integration side on Prometheus towards Kubernetes. And then eventually I also became and which I am still to this day, tech lead for the special interest group for instrumentation on Kubernetes side. So kind of in both directions, maintaining the integrations. Yeah.
Awesome. And we've talked a little bit about observability. I'd love for you guys to highlight for us, why is observability important in today's DevOps landscape? And maybe you can distill for us, what observability is to start, and then its importance in DevOps.
Yeah, I think a lot of people, any complex system, the one complex system that I think most people are familiar with is like their car. So if you want to know why observability is important, imagine driving a car with no dashboard, no speedometer, no gas meter, nothing. And if you really want to be of interest, no Google Maps, right? Like you literally just get in your car, just like hopefully you can find the spot by making the right turns. And so that's what happens when people don't have observability. And you'll be surprised that there are so many, I would probably say the majority of companies do not have any observability. They're just relying on tribal knowledge, looking and poking in the right place. They rinse and repeat this. And this is why tools like PagerDuty are so popular, because you have no idea what's going on until you get the out of gas, right? You're just on the side of the road and you're calling the tow truck. And a lot of people have been driving tow trucks for a long time. So this whole observability movement is about being very explicit and deliberate, not necessarily collecting all the stuff. That's what people used to do with just like old school monitoring, put a bunch of probes that don't necessarily tell you anything. I think the observability movement is about being very explicit. So then you add a speedometer because you want to know how fast you're going. You add the gas meter because you want to know how much gas you have left and how far you can go before stopping. So I think that's what the observability movement has been all about, this deliberate collection of data to aid you in operation of complex systems.
The way that I often describe it is, in terms of our software, anything that allows us to understand our running systems better. And so that can be a wide array of types of data, right? Like we often talk about like the 3 pillars of observability with like metrics, logs, and tracing. But really part of our philosophy at Polar Signals is to kind of break out of that notion, because while I think this has been really useful to kind of help adoption, because like humans like the number 3, and it was a useful framework in the beginning, I think. But at the same time, because we've had this framework, it's kind of trapped us in this thinking that this is the only thing we need. And with Polar Signals, we're trying to explore also some other things, and they're certainly complementary to the traditional observability. Like metrics are definitely still super important. Logging is super important. Tracing is incredibly powerful. But there are really a lot of other types of data that show us different perspectives of our running systems.
So Kelsey, you called it old school observability and new school observability. What is new school observability?
Well, so I think kind of old school monitoring, right? So monitoring was like, hey, let's just put probes kind of in random places, and you just got this stream of data, right? The CPU load is 3. How do you know if that's good or bad? Should you do anything about it? And so people would just make an arbitrary guess, like it should be 2 because we think 2 is like a better number than 3. And so then you just have people scrambling, and then they would scramble and say, all right, let's make it 4. And so years would go by, and it's like, why is it 4? I don't know. Someone set it to 4. Less than 4 is good. And so now that it's 5, we should all wake up. And so that's what I mean by kind of old school. We weren't thinking about this from a point of observing. We need to observe the system. And so when you're observing systems, you ask yourself, what am I looking at? What should it look like? And that takes time. So I think the modern platforms are doing a couple of things. Frederic kind of mentioned this need to get other signals than just the top 3. Like even in your car, going back to that analogy, there are sensors on the tire to check tire pressure. It may not be the number one thing on your dashboard, but that sensor's in play because we know that low tire pressure contributes to bad fuel economy. So we put complex sensors that are very deliberate because we want to observe the driving conditions, because that contributes to the whole. And so when the tire pressure is off, then we can go and ask ourselves, that's why you're not getting the gas mileage. So I think observability allows you to answer questions, whereas monitoring is just data and you have to parse the data yourself.
So Frederic, why don't you give us a little bit of background on continuous profiling specifically and how Polar Signals fits into the broader observability landscape?
Yeah, so continuous profiling really, maybe let's start with normal profiling before we go to continuous profiling, because that's really where the idea originates. So profiling has really been around pretty much as long as software engineering has. And profiling essentially allows us to understand resource usage of our running programs, right? So how much CPU is being spent, but not only on a high level, not just on a process level, but down to the line number. Which of my functions and my line numbers are using my CPU time, or which line numbers are causing allocations, memory allocations. This can be really also a wide array of types of profiles, but it really always is that type of resolution and that type of detail. And there's really no other kind of observability data that gives it to you in quite that detail that you can jump directly into your code editor and make changes as you observe your data. And as I said, profiling has been around ever since software engineering has, but there have kind of been a couple of problems with it. One was just, it used to be a really intense task to do. We used to, and sometimes you still want to do this, do like true traces of what your programs are doing. You literally observe absolutely everything your program is doing. And then these we call trace profilers. And then there are also sampling profilers, where we only look at what our program is doing, let's say 100 times per second. And this makes recording these profiles possible at really low overhead, because, we're not tracking absolutely everything it's doing anymore, but still often enough that statistically speaking, we're catching everything that's significant. I think this is kind of happening in continuous profiling as well, where we used to have profiling that we did ad hoc, we did it once at a particular point in time, and that was useful and representative of that point in time. But as it turns out, our software often goes wrong when we're not looking, right? And so continuous profiling is about always observing our software and always profiling our software, so that in that instance where we're not looking, we're still collecting that data.
So Frederic, Parca is the backbone of Polar Signals. It's an open source project that is behind Polar Signals. Can you tell us just a little bit about Parca itself, the folks that are using it, and some of the applications that it's being used for?
Parca, the open source project, was really, it's kind of almost the second or third iteration of all of this. Actually, the very first iteration was kind of a proof of concept I put together a couple of years ago that I creatively named Conprof, continuous profiling. And I actually got incredibly lucky and got to present it at the keynote stage at KubeCon in Barcelona. I never, until I started Polar Signals, I never put, a full-time job into it. So now that we finally could, we did. And it's really, the analogy is kind of very similar to Prometheus. And I'm sure a lot of what went into Parca has been inspired by me working on Prometheus in the past. It's kind of this single static binary that is incredibly easy to deploy. It has zero dependencies. You just deploy it into your Kubernetes cluster. And we actually have two components. So we have the server and we have an agent. And the agent is also super interesting, where the agent uses eBPF to collect this data at even lower overhead.
And it'd be great to talk through some of the use cases. So, you've got folks out in the world using it. You've built a business around Polar Signals. Who is your target customer, and what are they excited about here?
Yeah, so originally I built this for myself because I was excited about this type of software and I wanted to have it while I was working on Prometheus and Kubernetes. And as I explored the space even further, I kind of realized that it's really super similar to the rest of the observability and monitoring space. Basically, every company that has some sort of software running needs this type of software, because everyone, just an example, one of the biggest things that people want to use software like this for, and this is also something Google has written about, is cost optimization of their cloud builds. Because we understand what it is that is using our CPU time or our memory allocations, we can target those optimizations because we know what to optimize, right? If you don't measure, you don't know. And so that's incredibly powerful. And it's kind of a relatively simple conversation to have, because who doesn't want to save money on their cloud builds, right? But really, the list kind of goes on. Another really important aspect of continuous profiling, or profiling in general, is optimizing latency, right? And so we're talking to several retail companies, e-commerce companies, and there's a very well-researched kind of piece of knowledge where any interaction with a software system that is less than 100 milliseconds feels instant to humans. And if it feels instant to humans, that boosts conversion rates. And so not only can companies save money with this type of software, but they can also make more money because it boosts their conversion rates. And so those are definitely some of the biggest use cases, but truly understanding our software down to the line number and allowing us to understand change, what caused, what was different at this point in time versus this point in time. We can truly see which lines of code were being executed and which weren't, right? This is just a level of depth that's really, really unique to profiling data.
Yeah, Dave, I think it's important to understand why this is possible. A lot of people hear this and say, well, why now? Why didn't this happen 10 years ago? And And I think, I remember I used to have like a 86 Jeep Cherokee. And I remember I failed emissions tests. And I think some of those cars in the earlier years, they didn't really have that diagnostic port you can just plug a tool into, push a button, and it will tell you everything. Here's what this component is doing. Here's the air mixture. Here's this. And it would almost pinpoint to exactly where the issue was. So they would say, all right, you failed because of this $2 component. We're going to swap it and rerun the test. That's what you can do. And the Linux kernel recently added that diagnostic port for the whole industry, not just for this use case, but in general. You can now plug into something purpose-built at a layer that's at the core where all applications and networking runs. And that's the whole beauty of eBPF, is that now that we have this socket, it's sitting there. Now the ecosystem has to go build those diagnostic tools, the visualizations. So all the infrastructure mechanics out there, the developer mechanics out there, instead of them guessing, try it now, pour a different type of gas in there, that's out. Now you can just plug in, hit the button, it says, this is exactly where you need to focus your attention. And this is where all the innovation and this is where all the saving comes from, because we now have a place to do it.
So the three major clouds all have access to this port that you're talking about, eBPF, the analogy you're using with this diagnostics port. Why wouldn't the three major clouds create the products that would allow for continuous monitoring of these diagnostics? Why does this tool need to exist in a third-party open source company?
Well, the truth is, no, not all Linux distros deployed to the cloud actually have this version of Linux that has this enabled. It's getting there. The gap is closing over time, but you got to remember, people are running different versions of the operating system. So a cloud provider is based on scale. So I can't necessarily make this the default option and build every one of my other tools, assuming everyone's going to be using a modern version of Linux to pull this off. So just like any other startup, right, you're trying to be ahead of the game. And so for the newer Linux kernels, look, and what did they say? It's easy to predict the future when you're working on it. So a lot of the startups are working on the future because no one really thought about using eBPF solely for this type of purpose, especially extending it to debugging applications. Typically, we stuck profilers in the app itself. So now we're taking a more general approach. So this is just really ahead of the curve. So I think cloud providers could do it. It's all about when to do it. And startups are like, let's do it now. And then let's make it easier to do in the future. So I think this is why you see startups kind of really leading the charge here.
And Frederic, can you talk a little bit about your differentiation versus other startups that might be pursuing a similar approach?
Because we're independent, it means that we can run on any cloud provider and give you an analysis maybe across all of the clouds that you're running on, right? So we could even do comparisons of compare my entire data center to my other data center because maybe you're trying out new hardware or something, right? So I think decoupling yourself from that is already kind of a win because it means you can make free decisions by yourself. But in terms of differentiation about the tech itself, so one thing that we felt really strongly about is that we felt like the collection mechanism using eBPF, it's got to be open source. And there's really no other equivalent in the open source world right now. The reason why we feel so strongly about this is because in order to execute and load eBPF programs, you've got to be root. And so we think everybody needs to be able to inspect this code. And we went much further than that. We have reproducible binaries, reproducible container images so that people can truly verify that the thing that they're deploying is 100% the thing that the open source community has built. So we've thought a lot about the security aspects to make a lot of people comfortable with using this type of technology. So that's definitely one thing. The eBPF thing, for a start, is definitely very new. There are certainly lots of profiling providers out there, but there are only very few that do any type of eBPF. And I think the kind of combination of ecosystems that we went with is completely unique in the ecosystem. So I guess here my kind of Prometheus background also came into play. We kind of look at a series of profiles, kind of similar to time series in Prometheus, and we label them in exactly the same way. And so this creates incredibly powerful workflows where you can now all of a sudden, jump from your Prometheus latency metric to a CPU profile at the same time, simply because we have the same metadata model, and it just makes it super, super easy to do that. And then the other side, again, from my kind of background, we have a very deep Kubernetes integration where you just need to deploy this agent to your Kubernetes cluster. It discovers all your containers on your Kubernetes cluster and automatically starts profiling them. So you have to do absolutely nothing. You get metadata for free because we attach, the node, the namespace, the pod, the container, all of this wonderful metadata so that you can focus on what you need to do, which is optimize your application, right? And all of this other stuff is automatically done for you.
I'd love to talk a little bit about the future and where this is going. And so, you both spend a lot of time thinking about the future of DevOps, the future of infrastructure, the future of Kubernetes. So how big could this opportunity become over time? And what are the different directions that you could take as a company here? And what are you excited about over the coming years, Frederic?
So I'm super excited about everything that's still happening in the eBPF space, right? Like, it's incredibly open technology, right? Like all of the hooks have kind of always existed in the kernel that we're using, but now they're just so much more accessible. And like every week I discover something new that someone did with eBPF that was just unheard of before because it was just completely inaccessible before. So that's really exciting. And we're certainly experimenting with a lot of things in the eBPF space that, go even further than continuous profiling. Potentially, we can build debuggers with this type of technology where we can debug in production. But I think the traditional observability space is still super valuable. So I think this could also be something where we will eventually tap into.
What we're seeing is really a maturity of this whole discipline, this software engineering discipline, right? It's been a lot of trial and experiments for the last 30, 40 years. And as we mature, we get defined interfaces, APIs, schemas, practices of turning into products. That's kind of what we're seeing here. And what's going to be the driver for this is that, I think recently as this month or even next month, US governments and government entities around the world are going to want to have things like secure software supply chain attribution to the software you're producing. We know that's only the first step. This software was built in this manner and it contains these dependencies. So they're going to want a software bill of goods or bill of materials. What's in this thing before we deploy it? We know what's coming next. What's coming next is what is it doing? And this is where the profiling gets into play. This idea of just guessing and reacting to bad things that happen months after they've happened will no longer be acceptable at some point into the future. So just like your car has VIN numbers so we can track that car moving around the world, that car is going to also have to emit data about how fast it was going, its emissions to make sure that it's adhering to rules and regulations. So the other part of this equation is going to be, what is this software doing? So we're all focused on what is the software. Then we're going to shift focus to what it's doing. So this is the early jump on it, but I guarantee you at some point, there will be a requirement that you would have to have the ship log of where this thing is gone, what it did while it was there, and how much did it weigh along the way to make sure you didn't lose some of the cargo in the middle of the ocean. So I think this is just a necessary thing around the maturity. And until these tools become commonplace, it's going to be hard to reach those goals.
I love all of your analogies, Kelsey. It's like it's so accessible when you compare the most technical infrastructure components to cars and ships and things that are much more relatable. That's fantastic. It's a skill of yours. Frederic, you've been a part of multiple great open source products. You have, obviously been deeply involved with Prometheus and now Conprof Parca. Curious to know, there must be inflection points. And in fact, I know there are inflection points where people come to you and say, this product would be great in a particular vertical. Rather than building horizontally and creating this, continuing to create best in class open source tooling, open source products that can be applicable across a lot of different areas. Focus on cyber, focus on APM, focus on infra monitoring. How do you choose whether you stay super broad and create best in class tech, or focus on the verticals that will drive applications and revenue over time?
So something that we've been super deliberate about is that we not just create a continuous profiling product, but that we create a continuous profiling platform. And like we've very deliberately designed our APIs so that people can really take this data and make it their own. Like we've started to see people who suggest, hey, this would be cool if I just write a CLI tool and stick it into my CI system, because then I can compare my before and after of my software, like as I start to roll it out. So like I think that's part of the key of creating a community and an ecosystem, is not just focusing on creating one great product, but creating an API to interact with data. And I think this is what truly makes things powerful. And then I think it tends to crystallize what the biggest opportunities are. And we got to listen to the community then.
I wanted to take a bit of a left turn here and talk a little bit about building companies remotely today, and that you are not, we talk about funding companies all over the world. You and I have never met in person. We've only spent time together on video. You sit in Berlin. I sit in California. You're running a company with people from all over the world. What is that like? And is this the new world? Is this where everything is going? Maybe including big companies in the future? And I'd be curious to get both of your perspectives.
Yeah, I mean, for us, in a way, we were forced into it, right? Like, Polar Signals was founded like in the middle of the Corona pandemic. So yeah, if we weren't forced into it because of that, we definitely several of us at Polar Signals have had full remote or at least partial remote experience, and so we definitely very intentionally tried to build a culture at Polar Signals that allows us to be a remote company forever. And part of that is, you need to adapt the way that you communicate, especially, we're spanning time zones from India to like Minnesota in the US right now. So that's like 10 and a half hours of time zone range. So you can't do it. You have to do asynchronous communication. And one of our key kind of pieces of culture is something that we call like, when in doubt, write it out, where we have very strong document-driven culture where anytime we have a larger undertaking, we start with our RFC process where we write down our thoughts and we crystallize our thoughts in text, and that's how we then asynchronously communicate. And as it happens so often, as you crystallize your thoughts in terms of text, sometimes the solution even becomes obvious, and you never needed a meeting to begin with. And so I've been loving it, and I kind of never want to go back for sure. And yeah, I'm just excited about the like talent that we get to access. We don't need to limit ourselves to the city we live in. As I said, we already have folks in India. We have folks here in Berlin. We're talking to people all over the world who want to join Polar Signals. So that's just incredibly exciting to me.
Frederic, I wanted to give you a second to, if you had any questions for Kelsey that you wanted us to talk through here.
I mean, I guess my biggest question is how do you see this type of technology fitting in? You work a lot with the with the serverless space, with the function space, like where do you see this type of thing fitting in? I, of course, have my ideas, but I'd be super curious to hear your thoughts.
Well, if it's successful, it will fade away and be everywhere. And I think the way to think about this is you almost have to operate like the Visa network. You need a terminal on every desk, every checkout counter. And so in your world, you would need these agents, these hooks, these diagnostic ports everywhere. And then if you do that successfully, then you can disappear. And the only thing that will be left standing is the things people will interact with, right? Something that says you can lower your bill if you just did this. This library is costing you a fortune. You should swap it out for this other one over here that we know for a fact uses 50% less CPU. This is where things become magic. So while customers and we're all excited about the technology, and we got to do that, we got to start somewhere. But you got to go from inventing the wheel to inventing the car. And if you invent the car, then you can invent the destinations like the beaches where people drive to experience things. And then the tire fades away. So I think you got to keep the eye on the prize. What is this technology designing people to do? And your vision has to be so clear that when you're talking to people, you're saying, hey, today in serverless, you're dealing with the black box and you're guessing. Or we're going to remove the need to guess going forward. And your life is going to look like this. So I think that would be the thing. Think about the whole timeline. You're just here now. You're just starting. And so this famous phrase we have internally at Google is respect the opportunity. The opportunity isn't to use eBPF better than anyone else. The opportunity is to make no one have to know it's even there.
Kelsey, I'd love to chat a little bit about your work with GV companies more broadly. You mentioned being able to tell stories crystal clear, and I think that's a huge strength of yours, being able to very simply and clearly articulate something that the rest of the world might feel like is extremely complex. You're a teacher, you're a communicator, a crystal clear communicator. How do you coach CEOs? You spend a lot of time with our CEOs, right? We formally work with 4 or 5 companies. You've probably coached a dozen or more companies across our portfolio, maybe 24 at this point. But what are those conversations like? How do you think about teaming with CEOs? Tell us a little bit more about the work that you do with GV.
Yeah, so when I get with the founders, as someone who's been in a lot of product companies, I've been at Puppet Labs where there's been an open source and all the battles we have between open source versus enterprise. Like I've been doing this for so long. I've also been a customer of these products and services where I had to decide what to buy and buy the wrong thing and then have to go buy something else again. So I have empathy for the whole process the whole way through. So when I meet a founder and I meet a team, I ask them, don't tell me what you're doing, tell me what you believe. And it's really hard to get to that next level of the human part of this. Right? Look, we are building this thing. I get that part. But what do you believe? Are you building the right thing? Do you really believe that a developer is going to write faster? If you really believe that, could you show me? And if you can't show me, like when you're showing me something, you don't show me with the slide deck. You're not going to bring a PowerPoint with 12 slides on it to prove to me. You're going to say, hey, come over here. You see this Go application? I'm going to tell you exactly what library. I've never seen the app before, but I'm going to tell you right now which library is costing the most money in terms of CPU utilization. I'm going to do it in 5 minutes. And they're going to be so amped up. Their eyes are going to light up. They're going to move their fingers like, a pianist playing the piano. And they're going to point to it and say, it's that library right here. I'm going to swap it out and prove to you that it's no longer the problem. And now I know what they believe. And those are the stories because you're trying to get the other person to believe that this is true. So when they download the product, you got their attention. They're going to give you a little bit of trust. And if it actually works the way in which you've told the story, they're going to go tell the exact same story with the same emotions attached to it. And so that's the way I get with the founders. Tell me the story that you actually believe. And if they don't believe it yet, some people don't really believe it because they're yet to experience it themselves or they've forgotten what that initial experience was like. And Fred, you can probably attest to this. That first time you get something working in a way that's like, wow, this is going to change the game so much that I'm going to leave my job and go start a whole company and risk everything. It's that feeling that you must preserve and you must communicate effectively and consistently to everyone else. And so that's what I do with the founders. I just remind them what they believe.